The next section is on microscopes. A compound microscope is used to view structures that are not visible to the naked eye. And most compound microscopes can magnify images anywhere from 40 to 1,000 times its normal size. So now looking at the first features of the microscope, we first have the head, the arm, and the base. The head of the microscope is the part of the microscope that provides attachment and support for the objective and ocular lens. It also serves as the support for the eyepieces. The arm connects the head to the base. When transporting the microscope, always grab the arm with one hand. Then we have the base. This is the bottom part of the microscope. It supports the entire microscope and encases much of the electrical wiring. When transporting the microscope, one hand should always be placed under the base for support. So you're always going to carry a microscope with two hands, one on the arm, one on the base. Next, we have our voltage regulator. You might also see it as your light control, our illuminator, and our power switch. Now, the light control is typically a rotating or sliding knob that alters the voltage going to the substage lamp to regulate the brightness of the light. The illuminator contains the bulb, which illuminates. Then the power switch is usually located somewhere on the base of the microscope and is used to turn the power on and off. Next, we have our eyepiece. So this is magnifying everything by 10 times what can normally be seen with your naked eye. The eyepiece is a part of the microscope that you look into. And you always use both eyepieces and have both eyes open when looking in. The eyepiece itself is movable, so you can adjust them to the width of your own eye. Next is the ocular lens. So the ocular lens is going to be inside of the eyepiece, and it's going to be the glass portion that you look into. These lenses are located within the eyepiece, which generally magnifies the specimen the 10 times the normal size. So the eyepiece itself contains the ocular lens, and the ocular lens is the 10 times the magnification. Then you have the field of view. So the field of view is a term that describes everything visible when looking through the eyepieces. Next, we have our objective lenses. So it would be these 4 lenses and our revolving nose piece. A typical microscope has 3 objective lenses, though some have 4, as we can see on this model. Each objective lens has a label that tells how much it magnifies the image. For instance, a 4 times objective lens magnifies the specimen 4 times its normal size. The lowest power objective lens is 4 times, and it's also called the scanning objective. So in this case, we have right here our lowest power, which is 4 times your normal viewing, and then we have our 10 times, 40 times, and in this case we have our 100 times, but we will not be using that in this class, obviously, since we're not in lab, but normally we wouldn't use that anyways. So when looking through a microscope, when you're looking through your ocular lens and you're looking at your lowest power objective, which is your 4 times, you are actually looking 40 times the total magnification, because you have 10 times and 4 times. That's 40 times. And if you were looking through the microscope and you were looking at the mid power, which is 10 times, you would have 10 times 10, which is 100 times the normal magnification that you would see with your eye. And then last, if we were looking at the highest power in this case, we would have 10 times the 40 times, which is 400. Now, the revolving nose piece holds the objective lenses and can be rotated. So on the quiz or practical, if I put an arrow right here and say ID feature, this is your revolving nose piece. If I say ID feature, be general, objective lenses. Now, I may ask you on the practical to tell me the total magnification when looking through the microscope. In this case, if I was pointing to the 4 times or the lowest power objective, and I said, what is the total magnification when looking through the microscope on the lowest objective? You would say 40 times. However, if I said, what is the total magnification of the lowest power objective? You would just say 4 times. So I will be very specific with my wording, which you will have to pay attention to. Next, we have our mechanical stage. So our mechanical stage is the platform that holds the specimen. It also contains clips called your mechanical stage clips that hold the slide in place. So we can't really see it on this image, but it's this slight silver sliver, and this would be your mechanical stage clips. If I said ID feature, you would say mechanical stage. If I was pointing to the clips themselves, I would say ID feature, you would say mechanical stage clips. Next we have our lamp. So the lamp sends light through the specimen and it can be adjusted with the brightness with the control knobs. Next we have our coarse focus adjustment knob and our fine focus adjustment knob. Now the coarse focus adjustment knob is used to adjust the focus when viewing the slide with the 4x objective only. Do not use the coarse focus adjustment knob on 10x or 40x. Now the fine focus adjustment knob is the sharpened focus knob. It can be used with all of the lenses. So the larger one would be our coarse focus adjustment knob. The smaller one is the fine focus adjustment knob. And again, you would only use the coarse focus adjustment knob on the lowest power, which is 4x, and then your fine focus adjustment knob can be used on any of the powers. So our low power objective, mid power objective, and our highest power objective. So when looking at a specimen, the first thing we need to do when looking through a microscope is first plug it in. Then we would put the specimen on the mechanical stage. However, before doing this, we must make sure that the lowest power objective is rotated by the nose piece. So we must look at the specimen first through the lowest power, and then we can move it up to the mid and high once we use the coarse focus adjustment knob and focus in on that specimen. So once we find our specimen and it's focused on the 4x, we can then move it to the 10x, and then we would use the fine focus adjustment knob to make it clearer. Once we see the specimen clearly, we can then move it to the 40x. So again, that would be our 400 times total. Always start with the lowest power and then work your way up. Then once you find your specimen on the 400 times, you would then either take a picture or draw a picture of it, and then you would move the highest power back to the lowest power. So you would move it from that 40x to that 4x. You would then move down the mechanical stage, take the clips, open it up, and then take the slide off of the mechanical stage. Once you are done, you would turn off the power, you would unplug the microscope cord, and then you would wrap it around the microscope. And just to repeat it one more time, things to always remember when you're putting away your microscope: you would start on the lowest power, your red objective lens. You would have the stage all the way down. Then you would put your slide on the mechanical stage, move up the stage so you can focus on your specimen. Once you focus it, use your fine focus adjustment knob or even your coarse adjustment knob. Then you would move it from your red to your yellow to your blue. So our red is going to be our coarse and our fine adjustment knob. Our yellow would only be the fine, and the blue would only be the fine as well. And usually in the class we would draw pictures or take pictures through the microscope on the highest power, which is our blue, which is our 40 times. That's it for our microscopes.